This question is asking us about action-reaction pair forces. So that's dealing with Newton's third law of motion and the fact that it says that all forces come into pairs, an action and reaction. Let's go into more details about Newton's third law before answering the question. First, saying action-reaction is a little bit of a misnomer. It makes you think that after the action happens, something has to think it over and then come up with a reaction. That's not the case. All forces come into pairs. They come together. For example, if I hit the wall with my fist, so my fist hits the wall and the wall hits my fist at the same time. It's not that the fist hits the wall and the wall thinking, should I talk to this guy's wife? Should I call the police department to complain about this guy? No, the forces happen at the same time. Fist hitting the wall, wall hitting the fist. Now, these action and reaction, let's try to remember three things about them. They are always opposite in direction to each other. If one is pointing towards the left, the other would point towards the right. If one is up, the other is down. If one is north, the other is south. They are always opposite in direction. The second thing to remember about the action and reaction, they are always equal in amount. Their amount is equal. No matter what happens to the objects that are involved in that interaction or the size of the objects that are involved in the interaction. Irrelevant of either one of these, what happens to them or what were they. Irrelevant of that, the forces are going to be always equal in amount. So if a car hits an identical car, the action and reaction are equal to each other. If a bug hits a car, the action and reaction are equal to each other. It does not matter what happens to the car, what happens to the bug, the forces are always equal in amount to each other. The third thing we need to remember, and the most difficult to apply, is the fact that the action and reaction involve the same two objects. If object 1 acted on object 2, the reaction is going to involve object 2 acting on object 1, with nothing else coming in between. For example, as I'm sitting here recording this answer, the Earth is pulling down on me with a gravitational force. So the two objects involved here are me and the Earth. The reaction is going to be between me and the Earth. It has to be the same two objects. So the reaction is going to be me pulling up on the Earth with a gravitational force. Now, it's not going to be the force that the chair is going to exert on me. For example, the chair is pushing up on me. That's not the reaction to my force. That's another force. The chair is holding me up because my bottom is pushing down on the chair. That's another action-reaction pair. For the gravitational force, Earth is pulling down on me, I'm pulling up on the Earth, the same two objects. These are the three things to remember. So now let's focus on this question. So we need to look for the same two objects, opposite directions, and then equal amounts. So the first one here, what does it say? A rifle pushes a bullet forward and the bullet is slowing down by air resistance. So we have rifle and bullet, and then suddenly we have air resistance. So we don't have the same two objects. So this is not an action-reaction pair force. Now, two ice skaters, John and Elisa, push off from one another, from each other. As John pushes Elisa forward, his muscles push him backwards, causing him to slide across the ice. So we are seeing here John pushes Elisa forward, but we don't have Elisa pushing back. So that's not an action-reaction pair. The reaction should involve Elisa pushing back. So this is not an action-reaction pair either. A kangaroo pushes off the ground, and the ground pushes the kangaroo forward. Okay, here we have the same two objects. Kangaroo and ground, ground and kangaroo. That's my action-reaction pair. Let's make sure that we are correct by reading the fourth answer. A ball is hit by a bat, and the force of gravity pulls the ball downward. So here the two objects, ball and bat, but here we don't have the ball and the bat anymore. So that's not an action-reaction pair. So our answer should be the one with the kangaroo.